Okay, here we go. We're doing section 4.4, trig functions of any angle. Okay, let 4, -3 be a point on the terminal side of theta. Determine the exact values of the 6 trig functions of theta. So when we see 4, -3, we know that is a coordinate point. And so we're going to go ahead and draw our x, y axis. And we're going to graph the point 4, -3. So we go over 4, down 3, there's our point, and it's saying this point is on the terminal side of an angle. So this is our initial side, this is our terminal side, and this is our theta right in there. So what we think about when we've got this point 4, -3, we know it's not a unit circle point. It is a right triangle trig point. So, well, it's not really a right triangle trig point, but we know we have to use right triangle trig for this. So what I like to do is I like to take this triangle that's here and flip it up to look at it so that we can have side of 4, opposite side is 3, and if we use Pythagorean theorem, we're going to get this hypotenuse as 5. And so when we look at this, it's really easy to just look at the triangle and do right triangle trig and find out that sine is opposite over hypotenuse, so that means it's flip. Its reciprocal is 5 over 3. And then we've got cosine theta is adjacent over hypotenuse, so its flip, its reciprocal, secant, is 5 over 4. And we can also tell that tan theta is opposite over adjacent, and its flip, cotan theta, is 4 over 3. But then we have to remember our triangle is really in the fourth quadrant. And in the fourth quadrant, we have to remember, stepping on my microphone. Okay, in the fourth quadrant, we have to remember that both cosine is positive, sine is negative. And let's stop for just a second and look at this. Okay, so it's really important to remember when we're doing problems that involve both a right triangle and a point on the in one of the four quadrants. It's really important to remember where cosine and sine and the other 6 trig functions are positive and where they're negative. And this stems from when you have a point in the first quadrant, it's going to be where x is positive and y is positive. And so that means, since cosine matches up with x, that cosine will be positive in the first quadrant as well as sine. And then you can take it from there, because we know that if cosine's positive, then its reciprocal will also be positive. So all of these came from just thinking about plotting a point in each of the quadrants. If I plot a point in the second quadrant, my x is going to be negative and my y is going to be positive. So that's why the cosine's negative and the sine's positive, and the other 6 trig functions are as they are. Same thing here. If I'm going to plot a point in the third quadrant, my x will be negative, my y will be negative, and that gives me my 6 trig functions. And then if I was going to plot a point in my fourth axis, my fourth coordinate. It's been a long day. This is after 3 o'clock. It's 3:15, teaching a lot. Sorry if I just stumble over my words here, but in the fourth quadrant, the x is positive and the y is negative. Okay, so when we look at that, we come back to our right triangle and our 6 trig functions, and we realize, well, if we're in the fourth quadrant, cosine remains positive, but sine is negative. So I'm going to put a negative here, and that means its reciprocal is also negative. And since tan is sine over cosine, if I have a negative over positive, that means tan is also going to be negative along with its reciprocal. So a lot of people prefer just to leave their triangle right here, and then they don't have to remember. They can use this as a 4 and a -3. That just feels funny to me, because distance is never measured with a negative. So you can do it either way. You'll get the same answer. Okay, let me just check. Okay, our second problem says given cosine theta is equal to negative 2/5 and tan theta is less than 0. Find the values of the 6 trig functions of theta. So I'm not given a point, but I definitely recognize that negative 2/5 is not a unit circle value. So I need to make my right triangle and use right triangle trig that says since cosine is adjacent over hypotenuse, and if cosine theta is equal to negative 2/5, then I know that my adjacent's 2 and my 5 is my hypotenuse. So I'm going to do quickly, let's do Pythagorean theorem. We'll do 2 squared plus our missing leg squared equals our hypotenuse squared. So we'll have 4 plus x squared equals 25. So x squared is equal to 21. So x is equal to square root of 21. We will not change that into a decimal because it'll just be an approximation. So here we go. We can go ahead and ignore this. I can ignore the fact that tan theta is less than 0 and come back to it later. Let's just do right triangle trig and say, okay, here's my theta. So then I know sine theta is the opposite over the hypotenuse. And then my flip, cosecant theta, will be 5 over root 21. We can go ahead and rationalize. We can get 5 root 21 over 21. And then cosine theta is going to be adjacent over hypotenuse. And the flip of cosine, secant, will be 5 over 2. And then tan of theta will be opposite over adjacent. And the flip of tan, cotan, will be 2 over root 21. We can rationalize the denominator, and we can get 2 root 21 over 21. Okay, there are 6 functions, but we're not done, not quite yet, because in right triangle trig, if we don't know that we're in the first quadrant, then we're going to have to double check on the SIGNs. So when I look at the fact that cosine is negative, I stop and think about my quadrants. So I look at my quadrants and I think, okay, where's cosine negative? Cosine is negative here, and cosine is negative here in the second and the third quadrant. And so that doesn't give me enough information to know really what quadrant this angle theta is located in. So I have to look at the second piece of information, that tan theta is less than 0. Another way of saying that is tan theta is negative. So let's think about when tan is negative. Tan is negative when cosine's positive and sine's negative. So tan is negative here. Tan would also be negative where cosine's negative and sine's positive. So tan is negative here. So we're looking for a theta where both cosine of the angle is equal to a negative value, and tan of the angle is equal to a negative value. That's what less than 0 means. And the only quadrant that happens is in our second quadrant. So we stop and think about what are the SIGNs, signs, that kind of signs, for all of these 6 trig functions in quadrant 2. Well, we already said we know that cosine is negative, so we're going to have to change those, cosine and secant. We know that sine and cosecant are positive, and then we know that tan is negative, so then cotan would also be negative. We'll put that on the final answer. Example 3, evaluate sine of 3 pi over 2. All right, so when we're looking at 3 pi over 2, most of us already know the unit circle. 3 pi over 2 is going to be down here. What's the coordinate point when we're thinking about our unit circle? And we're thinking about the coordinate points for 3 pi over 2, x will be 0 and y will be negative 1. We know that sine matches up with y, so sine of 3 pi over 2 will be negative 1. Okay, when we look at cotan of pi, we're looking at where our theta is pi, and we're going to find cotan, so we're looking at the we're looking, I would pause. There's a student in the room, but if I pause, I'm probably going to lose this. Eric, do you need something? Here, you could come closer so I can hear you. All right, so here we go. Pi, the coordinates are -1, 0. And since cotan is, what do you need? A book? We don't have an outdoor book. Okay. So here we go. So cotan of pi, Eric, we'll talk about that tomorrow. Okay? Cotan of pi is the same thing as cosine of pi over sine of pi, and that's an identity we have to memorize, of course. And so cosine of pi, when we look at pi, cosine matches up with the x value, so that would be -1. Sine of pi matches up with the y value, that would be 0. Anything over 0 is going to be undefined, and that's the answer for cotan of pi. Okay, reference angles. We talked about them in class. Basically, the most important part of this, let's see, reference angle is an acute angle, which means that it's located in the first quadrant. That's important. All our reference angles are located there. And so when we look at this, at our unit circle, we look at, let's say, pi over 6, that is an acute angle, so that's a reference angle. And so when we remember our bow tie, that's how we're going to use it. If someone asks us to, oh, that's not very good, but oh well. If somebody asks us to, find sine of 11 pi over 6, we'll remember, oh, my reference angle is pi over 6. If you notice, everyone in the bow tie has a 6 in the denominator. And so you would refer to the answers for pi over 6 when they ask about the other radians with a 6 in the denominator. So same thing with the green. Once again, you don't even have to think about these bow ties if you decide to go ahead and memorize the unit circle and just write it down while you're taking the test to help you. But we notice in this bow tie, all the denominators have a 4 in them. And so the reference angle for any radian with a 4 in the denominator is pi over 4, because it's the acute angle in the first quadrant. Same thing with pi over 3. If you make the bow tie there, you'll notice that everyone in this bow tie has a denominator of 3. So any radian measurement, oops, what am I doing with a 3? The reference angle will be pi over 3 because it's the acute angle that matches with them in the first quadrant. So that's what they mean when they say reference angles. So let's look at the next one. It says evaluate the following trig functions, sine of 210. We could go about this a few different ways, but the way I like to do it is think about going around the circle and kind of stopping at each pi or each 2 pi. So as we're trying to find 210, we go around, and of course we know this is pi, but it's also 180. We're like, well, we're almost there. If we just do 30 degrees more, we'll get 210. So when you think about it, 210 is the reference angle. If you were going to look at this and think about the bow tie that this belonged to, it would belong to all angles who are 30 degrees away from the x-axis. So that means that my reference angle is in the first quadrant, and that is going to be root 3 over 2 and 1/2. So even though we are actually in the third quadrant, we can look at the sine value at our reference angle, which is 1/2, and then remind ourselves that we are in the third quadrant, so that means sine is negative in the third quadrant, and there you go. That's my answer. Of course, you can just memorize the unit circle and have it with you at all times. If not, that's the way you can go about that. All right, so cosine of -5 pi over 4. Once again, I do a quick little sketch. I don't have the unit circle in front of me, so I have to think about this logically. So -5 pi over 4, I know negative angles are going to be moving clockwise. And so let's see, negative 5 pi over 4 is a little bit past pi. Because, right, that's a negative pi, that's the same thing as negative 4 pi over 4. And then I've got to go another negative pi over 4 to get to negative 5 pi over 4. So go a little bit more, and there I see there is negative 5 pi over 4. If I wanted to use a reference angle for this, I would think about all the bow ties and everybody that's in the bow tie, and I would think, pi over 4, that is my reference angle, and all I have to do to find cosine, that matches up with my x value. So my answer will be root 2 over 2, and I will double check because really my angle is in the second quadrant, and in the second quadrant, cosine is negative, so my answer is negative root 2 over 2. Once again, when you're taking the test or you're doing your homework, if you have a unit circle in front of you, this stuff is easy. These questions really are trying to get us to more understand the unit circle on a deeper level. So try it. Try not to just go straight to looking at the unit circle. These are really going to help enhance your understanding if you can do it this way. 5 pi over 3, I think, that is almost 2 pi, right? 5 pi over 3 is the same thing as 6 pi over 3 minus pi over 3. So that's 5 pi over 3. So if I was going to sketch it, I would go all the way to 6 pi over 3, which is 2 pi, but I would come back pi over 3, which is right here. Okay, so I'd go this way first, and then I would back it up that way once I got to 2 pi. So if I think about the bow tie that 5 pi over 3 belongs to, it belongs to the bow tie that has all angles that are pi over 3 away from the x-axis, or 60 degrees away from the x-axis. So my reference angle is pi over 3, and my coordinate point there is 1/2 root 3 over 2. And then that gives me, since tan is sine over cosine, I would have root 3 over 2 all over 1 over 2, which either you can do it the long way or the short way, but your answer is root 3. So when I go to put my answer in, I have to remind myself, wait, but I'm actually in the fourth quadrant. So in the fourth quadrant, because cosine is positive and sine is negative, tan is also negative. So my real answer is negative root 3. Okay, example 5, let theta be an angle in the third quadrant such that cosine of theta is equal to negative 1/4. So let's remind ourselves that we are in the third quadrant. Even remind ourselves about who is what in the third quadrant. Let's see, cosine's positive, so secant's positive. I'm sorry, cosine's not positive in the third quadrant. X is very much negative in the third quadrant. Okay, let's try that again. Cosine's negative, secant's negative. Sine is negative, cosecant's negative. And then because tan is sine over cosine, so negative over negative is a positive, that also means cotan is a positive. So let's keep that in mind. Since cosine theta equals negative 1/4, it makes sense that it's in the third quadrant. I'm going to go ahead and draw my right triangle and do some right triangle trig because negative 1/4 is not a unit circle answer. So I'm going to ignore the negative right now. The negative tells me what quadrant the theta is in, but as far as right triangle trig, we do not measure things with negative units. So here we go. Distance right now, in our day and age, in the present moment, is always going to be positive. All right, so cosine is adjacent over hypotenuse. I'm going to go ahead and do the Pythagorean theorem real quickly. So we'll have x squared equals what? 16 minus 1, which is 15. So x is equal to the square root of 15. And we'll look at sine. Sine of this angle right here, this angle theta, sine is opposite over hypotenuse. So sine would be root 15 over 4, but then let's remind ourselves we are in the third quadrant where sine is negative, and so our real answer will be a negative root 15 over 4. When you're taking the test, make sure your negative clears the equal sign so I can really see that it's negative. All right, so let's look at tan. We're still looking at the same triangle. So tan is opposite over adjacent. So that's going to be the root 15 over 1, which is just root 15. And then we have to remind ourselves we are in the third quadrant where tan is positive, so we don't need to change a thing. Root 15 is our answer. Okay, in example 6, if the point 3, -1 is on the terminal side of an angle in standard position, find the requested values. Exact values, no decimals. Okay, here we go. So we're looking at, this is actually just like the first or the second problem we just did because they gave us a coordinate point, and we're going to be looking at this theta, and we are going to be making a triangle. Of course, I will flip my triangle. If that bothers you, you can go ahead and work with it upside down if you want. So in the triangle that we see, let's see, it's over 3. Oops, 1, 2, 3. Yeah, that's not too good. It's over 3, so 1, 2, 3. So my adjacent side will be 3, and it's down 1, so my opposite side will be 1. Once again, we need to do Pythagorean theorem, so we'll have 3 squared plus 1 squared equals hypotenuse squared. So we'll have what? 9 plus 1 is 10, and so the hypotenuse will be square root of 10. And then we need to remind ourselves that we are in the fourth quadrant. All right, so let's see. We've got sine, where sine is opposite over opposite over hypotenuse. So we've got 1 over root 10. We can rationalize it by multiplying by root 10 on the top and bottom. So we get root 10 over 10. Is sine, what sine in the fourth quadrant? Sine is negative. So that is a negative root 10 over 10. I'm going to flip it for cosecant, which I'm going to take my original 1 over root 10 and flip that. So I'll flip it and get root 10. Once again, since sine was negative, cosecant has to be a negative. Let's see. Don't want to confuse anybody. The negative root 10 over 10 was the final answer. But if we could take the answer with the radical on the bottom when we flip, it just makes it so much easier for cosecant, because then we don't have to rationalize the denominator. All right, let's look at cosine theta. In our triangle, cosine is adjacent over hypotenuse, so that's 3 over root 10. And when we rationalize the denominator, we will get 3 root 10 over 10. Cosine in the fourth quadrant is positive, so we can leave the answer alone. If we're going to flip for secant, we're not going to flip the final answer for cosine. We're going to flip the original answer, because then we won't have to rationalize the denominator for secant, because cosine's positive, secant's also positive. Okay, and let's move on to tan. Tan is opposite over adjacent, so it's 1 over 3. But when we think about the fourth quadrant, since cosine's positive but sine's negative, tan will also be negative, so we need to put a negative there. And that will be our final answer for this. And then, of course, with cotan, if we flipped it, we get negative 3 over 1, which is just negative 3. Okay. All right, and there's your homework, and I want you to remember, click on the blog for what we need to know so far. I added a little something to it. Please take care of your side of the responsibility for learning. Thank you for joining me, and I will see you in class.